Hello, mkhaya muli bwanji? Tikulandireni kuphunziro lathu lero imene tikuitcha kuti trigonometry. Our topic today is trigonometry, and you'll be with me, Cicero Juma. Let's look at some introduction concerning trigonometry. Basically, trigonometry comes from was borrowed from Latin. There are two words there, two Greek words. There is trigonon and metron. Trigonon means triangle, and metron means measure. In other words, we are going to use a triangle to measure distances, to measure angles. So trigonometry basically helps us find angles and distances, and this one mostly is used a lot in science, engineering, and video games, and of course many more areas. Now, in dealing with trigonometry, as I've already said, you might have done in the previous classes types of triangles, but today in this trigonometry, in this first part of trigonometry, we'll dwell much on the right-angled triangle. This triangle is the one of most interest in this lesson. It's a right-angled triangle. The right-angled triangle is as shown below. We have this one, triangle, where here we have this box here. It shows that this is 90 degrees. When we say right-angled triangle, it means the triangle has a 90 degrees somewhere. So this 90 degrees is represented by this thing here. Okay? That this box at the corner. So it shows that is a right-angled triangle. And this right-angled triangle has got more parts. And those parts, we have adjacent, we have opposite, we have hypotenuse, and we have theta. Okay? So in other words, we have that theta. If you look at it, the theta is the angle. It could be an angle, but the side which is opposite to the theta is what we call opposite side, and the side which is just below the angle is what we call adjacent, and the side which is opposite to the 90 degrees or right angle, it's what we call hypotenuse. So basically, those are the parts of a right angle triangle, and we need to understand all these parts. Why a right angled triangle? Why is this triangle so important? Okay, so let's look at this example here, where we just trying to imagine that we can measure this side, or we can measure the height, but we can't measure that distance. And we also want to know that angle. So the right-angled triangle can help us to find that distance, can also help us to find that angle. Or maybe we might have this scenario, that scenario there, where you know that side, you know this side, you know this angle, but you don't know from there up to there. And you also don't know from there up to there. So using right-angled triangle, you can easily find those distances. So that's why a right-angled triangle in trigonometry, it is one of the important elements. Now, let us look at trigonometric ratios. At the moment, we will look at the three trigonometric ratios, which are sine, cosine, and tangent, those ones. And short terms zake, sine is written as sine, cosine is written as cos, and tan is written as that. So, abatukuti ma ratios. We need to be together here. We are referring to the ratios. each and every triangle, most right-angled triangle, as we have said, it has sides. Now, if you play around with these sides, if you divide one side against the other side, mostly you create a ratio. And that's what we are referring to. So those ratios are defined here. Okay? We have sine theta. Sine theta. Sine theta is the same as to say opposite side divided by hypotenuse. If you take this side and divide by that hypotenuse, that ratio gives you sine theta. Okay? We are saying is, if you say opposite over hypotenuse, over hypotenuse, opposite over hypotenuse, it will give you that, opposite over hypotenuse, it will give you sine theta. So this one, or triangle, it can be any size, size in areas, but that ratio will always be the same. That ratio will always be the same. So it is of much importance. The same applies to cosine. For you to find that ratio cos theta, that ratio, you do adjacent over hypotenuse. So you're saying cos theta will be equal to adjacent over hypotenuse. So this ratio as well is always the same. But if you divide adjacent and hypotenuse, if you are dividing those sides. Okay? And the last one is tan theta. Tan theta is the same as to say opposite over adjacent. Opposite over adjacent. So if you divide this side and that side, it has to give you that ratio, which is called trigonometric ratio. I hope we are together reaching that far. For you to remember this, you can easily use the term so okay. S meaning sine, O meaning opposite, H meaning hypotenuse. So you'll see sine theta is equal to opposite over hypotenuse. So that stands for that. Cos theta is equal to adjacent over hypotenuse. Just like that. That's just a simple way on how you can remember these trigonometric ratios. Let's look at this simple example using a calculator. Okay. Yep. So you can have that triangle. We are saying cos. Let's start with sine theta, which we say is equal to opposite over hypotenuse, which is equal to in this case, opposite is 2.8. That's the opposite. And hypotenuse is equal to 4.9. Okay? If we take a calculator, so we are saying sine theta is equal to 2.8 divided by 4.9, which is equal to 4 over 7, 2.8 over 4.9. That one is equal to that, which is equal to 0.57, 0.57, and many other numbers there. Okay, so you can do that. So remember, we are saying you're going to do as well cos theta. This is just a ratio. Okay, is a ratio, which is 2.8 over 4.9. 2.8 over 4.9. That's a ratio. Okay. The same thing, cos. Cos is the adjacent over hypotenuse, which is equal to, our adjacent here is 4 over 4.9. So that ratio, you find out is 4.9. 4 divided by 4.9. That one should give you 0.81 and many other numbers. Okay, the same you can say tan will be equal to opposite over adjacent. So what is our opposite? Our opposite is 2.8. Our adjacent is 4. So we do 2.8 divided by 4, which is 0.7. So those are the ratios of that. Remember, we are saying whatever the size of that triangle, but these ratios will still remain the same. Okay, the triangle could be larger or smaller, whether you turn it around, but that angle will always have the same ratio. Now, let's try to use the calculators. If you look at the calculator on this one here, if you look at that calculator, you will see that there is a sine, there is cos, there is tan. Okay? Just like this one. There are these 1, 2, 3 functions. Those are trigonometric ratios in the calculator. Okay, so you can easily use a calculator on those trigonometric ratios to find those trigonometric ratios. All right, let's do that by looking at this example. Okay, in this example, we are trying to find the height of this tree. It could be you here, standing there. You are looking up at that angle, and you know distance from where you're standing to the top of the triangle, but you don't know the height of the tree. Okay, so how do you do that? This is how we are going to demonstrate here. So, as it is, we can't reach the top of the tree, so we walk away. Okay, we can't reach the top. We walk away and measure the angle using a protractor, okay, and the distance using a laser. You use a laser. A laser is an instrument. It's a technological instrument which you just beam a laser and it gives you that distance. So you can easily do that to find that distance. Okay, so in this case we know hypotenuse. We don't know the opposite. Okay, so but we also know this angle here. Now we need to use those trigonometric ratios to find this missing side, to find the height of the tree. So we are saying that. Remember, I was saying we can use this so. I'll put it there deliberately. So katoa. So in this case, we know we want to find opposite, which means there has to be O on whatever you're doing. You need to find opposite. We also know hypotenuse. We know hypotenuse. As such, these things, two things are here. We just have to now use these trigonometric ratios to say sine In this case, angle 45 degrees should be equal to opposite, which is that side, opposite over hypotenuse. Okay, hypotenuse. Alright? So, if you go into calculator, okay, so we'll find out what is the sine 45. Okay, let's go to calculator. Okay, let's look at where sine is. That one, sine. So we just put sine 45. Click what? That one. But we want it into that form. 0.7071. Okay, 0.7071. So that's that. Okay, that's how we do it. So what does the 0.7071 mean? This one is, it is a ratio of the side lengths. So the opposite is about of the side lengths. So the opposite is about 0.701 times as long as the hypotenuse. Okay? The opposite is 0.707 long than hypotenuse. Opposite times 0.71 will give you hypotenuse. That is what that means. Okay, so if we look at that, we have this now. 0.7071 is equal to opposite over hypotenuse. And we also know that the hypotenuse is 20. Okay, as already shown. The hypotenuse is 20. So, we knew the opposite was 20. So, as it is, we substitute where it was a sine 45 is equal to opposite over hypotenuse. Okay, so sine 45 we found to be 0.7071, which is equal to opposite, we don't know, that's the height of the tree, over hypotenuse. The hypotenuse we know. So we just have to make subject of the formula opposite. So opposite will be equal to 20 multiplied by 0.7071. Okay, so the opposite is 14.14 meters. That is to 2 decimal places. So that is, if we multiply that times 20, that's 14.14 meters. In other words, the height of that tree is 14.14 meters. Okay, you can do that in a simpler way. Okay, you just start by doing that. There we were just showing each other on how you can do it slowly by slowly. But in this case, you can just say sine 45. That's is equal to opposite over hypotenuse. Opposite that one over hypotenuse is 20. So you substitute on that one, sine 45, you put that, and you substitute the size of the hypotenuse with 20, and you make subject of the formula, that one. Yeah. So you do your calculator. It means the tree is 14.14 meter tall. Finally, let's look at this exercise together. Okay. In this triangle, we are assured that this triangle is a right-angled triangle because of that side, that box there. And we are given that angle. We are also given that angle. And we are given that side. Okay, so in this case, we have, I think, 2 triangles. Meanwhile, there are a number of triangles, but we are interested in 2 triangles. We have TQS, and we also have TQR. TQS has got an angle of 60 degrees. TQR has got an angle of 45 degrees. All these triangles have got common opposite, okay, which is TQ. All right, so let's look at what they want us to find out. They're saying in the above figure, calculate leaving your answers in side form. The length of TQ, the length of RQ, that is RQ, the length of RS, that is RS, from there to there. Okay, so having that, okay, so looking at this, the first question is for us to find TQ. TQ is that one. How do we find that? We can consider this small triangle TQS. In that small triangle, we have opposite, which is equal to TQ, and we have hypotenuse, which is equal to 8 centimeter. Okay, so from those ratios, we can say opposite hypotenuse. This is sine, if you are to use the SOHCAHTOA, okay, so it will be sine, opposite and hypotenuse is found there. So it will be sine, in this case, we are considering TQS, sine 6 theta will be equal to opposite, which is TQ over hypotenuse, which is 8 centimeter. Okay, which is 8 centimeter. All right. So, in other words, we want to find the value of TQ. All right. So, to find the TQ, it will be TQ will be equal to 8 times sine 6 theta, which will be equal to, let's take a calculator. Let's look for the sine, that sine, press that, then you put 6 theta, so 0, 6 theta, sine 6 theta, we know sine 6 theta to be 0.866. Okay, so it's 8 times 0.866. Okay, so if you multiply those ones, 0.866 times 8, it will give you 6.928. Okay, 6.928. So that's the value of TQ. All right, let's go ahead and find the value of RQ. So for us to find the value of RQ, we need to find using triangle TQR, the bigger triangle which has got angle 45 degrees. In this case, our opposite will be equal to the same TQ. Okay, that triangle opposite, that and that. So it's TQ opposite. And we have hypotenuse. We want to find hypotenuse, which is RQ. Okay, the same here, we still use sine. Sine 45 is equal to opposite, which is TQ, over hypotenuse, which is RQ. Okay, now you make subset of the formula RQ. It will be RQ will be equal to TQ over sine 45. Okay, so let's just put it here somewhere. So we are saying RQ will be equal to TQ over sine 45. Okay, so TQ tunampeza kale baja is 6.928. 9282 over sine 45. So let's do on the calculator what is the value of sine 45. It's 0.701. 0.7071. So if you divide that, our RQ will be equal to 6.9282 divided by 0.31. The answer will give us 9.79795, either meters or so. Okay, so that's the value of RQ. Okay, so I will leave you with the other part to do. That is to find the value of SR. Okay, the value of SR. For you to do that, you need to find the adjacents of the two triangles that we have shown. After you do that, you are going to subtract the adjacent of the bigger triangle. You subtract the adjacent of the small triangle from it. Day 22, so reaching that far. For today, let's stop there. Hoping to see you soon. Thank you.